Good evening, everyone. My name is Sarah, and as a day job, I am a cosmologist specializing in the first billion years of the universe, and more precisely, quasars and the first galaxies and supermassive black holes. And what I wanted to do this evening is run a dungeon in Final Fantasy XIV while just chatting about random astronomy stuff. I'm gonna queue right here, and more specifically, I wanna talk about this job here. So this job is a Final Fantasy special called the Astrologian, and there's a lot of words used to describe astronomers. So people have often asked me, what is the difference, between an astronomer, an astrophysicist, a cosmologist, an astrologer, and an astrologian? Why do you need so many words? We don't really, and all the meanings of these words have changed a lot with time, and certainly they mean very different things today. So if I can hopefully clarify some of that for you, and go in order. So an astrologer is someone who believes that the asters in the sky actually have the power to influence human destiny. It is, out of all of the words we're going to discuss, astrology is the only one that's not a science. It is mostly a belief, and I'm sure it originated in a time where it didn't even have this connotation. So astrology originally just comes from the words logi, so astro and logi, which just means logos, the study of. So it originated in a time where just describing what happens in the sky and just noting where all the stars are and how they move was all there was to the art. So that people didn't know what it was. Although over time, it's come to mean specifically when you believe that what happens in the sky actually affects your own life, which we have pretty good evidence that doesn't actually work like that. That stars are actually way too far away to influence anything. But it's still something that people believe in, I guess, although I don't personally. Now, the Astrologian, Astrologian, however you pronounce this, is a job in Final Fantasy XIV. It's a made-up word. It only exists in here, and I've had someone ask me why I play this job, if I'm not offended by the fact it's unscientific, and as an astrophysicist, should I really encourage it or be playing it? Well, I think in the universe of the game, it is quite clear that magic does actually exist. And if magic actually existed, then studying how magic works would be science. As long as you test different spells, you combine them, and you do it many times, and you controlling the RNG, doing it many times, will basically be like science experiments. This is really good because that's exactly what this particular job does. So it's a support job where you can combine different buffs and just craft the best buffs for your party. You can't really debuff people, but you have a large choice of healing and barriers and just all the ways to combine different magic spells and control RNG. So you draw a random card, it gives you a buff, and then you can change it. You can try to turn it into a buff for another card, combine different cards together with different effects, and so on. So it's not too bad. I think it makes sense. Okay, so I've got about 3 more minutes before we go in. Alright, so how about the other words? So astronomy is a word that's as old as astrology. I think originally those two things were not different because science was just saying what is in the world. It was not about understanding how it works beyond that. I think that's a dragon. Oh, that's pretty cool. Is it going that way? It's going west. There is actually the developers have actually implemented some basic astronomy in Final Fantasy XIV. I plan to make a series on that because actually the motion of the stars and how they change from night to night and from different locations in the world actually does make sense if you build a model of where the constellations are and how big the planet is. It's actually quite a a lot of cool science going on in there that the makers of the game have actually bothered putting in. So hopefully I'll get to that. I'm gonna go fix my gear while I wait. Right, so the other words. Astronomy is a very old word. And when it started becoming a science, and people started measuring, say, the distance to the moon, or the distance from the Earth to the Sun, and things like that, it was still called astronomy. So we didn't have a concept of physics to turn it into astrophysics. It was all encompassed in astronomy. The distinction with astrophysics really came about much later. So during the scientific revolution, when people were very keen on physics and hard science in general, and they really developed a culture of experiment taking instead of just scribbling some words and writing a philosophy treaty, which is what the ancient Greeks used to do. Right. So when really hard sciences started to become popular, astrophysicists were very keen to distinguish themselves from astronomers. Even though nowadays the two words mean basically the same. It's the study of what happens in the sky, but from a physical perspective, like actually describing what happens and understanding what happens. Like, what is a star? It's really, if you think about it, astronomer and astrophysics, the root astro just means an aster. So we don't really use the word aster anymore nowadays. What is an aster? It's really something that you see in the sky, like a blob of light. And I think back then, when the word was actually in use, the only things that we knew of in the sky were stars and planets. So I guess stars and planets are asters because they are round things that move in the sky. That's pretty clear. Right. Of course, there are other things that people can see in the sky, but they didn't really know about them. So even with the naked eye or with good binoculars, you can see galaxies or even accreting black holes. I think in the sky, a few of them. But people didn't know about that. So asters were just spheres that move in the sky, and that was enough to make a science out of. Now, nowadays, the words astronomy and astrophysics mean basically the same. There is a slight, subtle distinction, which is to do with amateurs. So you can be an amateur astronomer if you like, as your hobby, looking at the sky, maybe recording where things are, taking some pictures, astrophotography, and so on. But you can't really be an amateur astrophysicist. That is not really a thing. That would include actually doing physics, I guess. You would have to work out like making a model of the inside of a star or something like that. Which I guess you could do as a hobby, but that's not really what people do when they're keen on astronomy. It's much more common for them to just mean, I like looking at things in the sky, and I like buying expensive equipment. That's really all the distinction there is. In terms of a science, if you do a degree in astrophysics or a degree in astronomy, it is exactly the same. Like there is no difference there. It's going to be the same topics, it's the same techniques. You learn about how stars work. You learn about how fluids work in space. You learn about gravity, about quantum mechanics, about light. All these things. But it's really the same. And then, okay. So the reason we still have this distinction is mostly historic, and it's kind of just become a way to treat amateurs versus professionals, which is not really fair. It's not really fair, because a lot of astrophysicists that work as astrophysicists only have degrees in astronomy, so that doesn't mean anything. Alright. So I guess the more difficult one is the distinction with cosmology. So that's one that's a bit harder to explain. Because cosmology also looks at the sky. I guess it's become day in the game while I was talking. The queue is way longer than I expected. I mean, the whole reason I play Astrologian is for the shorter queue times. I mean, it's not my main. I usually play as a black mage, like so. But if you are a damage dealer in Final Fantasy XIV these days, the queues never end. So you just gave up. So I'm still trying to gather materials to craft better gear for my Black Mage. But the only way to get that gear realistically is to do the queues as a healer. So hey, I quite like the theme of the Astrologian. Anyway, spell. So remember what I said about there's actually an astronomy in this game to some extent. Like the whole law of the Astrologian is to do with learning the powers of each constellation and whatnot. I mean, yeah, which is interesting because there's this whole conflict with a geomancer who thinks that the same power can just come from the Earth. So it's a given that you get these magic powers, and like where they actually come from is not really established. I mean, this game is not particularly scientific. I think magic is not really usually treated in a scientific way anyway. It could be. Right, what was I talking about? Huh. Yes. I think yes. All right. So this particular job, Astrologian, is based on constellations, and that's how I got to notice that there's actually astronomy in this game. So especially there is this amazing skill that I think I don't need to let it buff. Okay, and this actually gives you the positions of the main constellations on the sky. So even though you're supposed to learn all the constellation names while you train to become max level at this job, I can never fucking remember them. So this is quite useful. So I've used this as a reminder of where they are. When I was trying to locate, like, for instance, where the North Star was. It turns out there's a North Star in this game. That's pretty cool. The wait time just keeps getting longer. I guess it's not even that late. Come on. Right, but I was talking about the difference between an astrophysicist and a cosmologist. And that is one that's a bit harder to explain. I like using the analogy of history and sociology. So they're both the study of people, and astrophysics and cosmology are both the study of the universe. But, broadly speaking, astrophysics studies the things inside the universe just because they are themselves interesting. Like, you don't need another reason to study a galaxy just because a galaxy is interesting. In the same way as sociology can study a society, or even a group of people, or even individual people and how they behave. You just study a society because that's interesting. Now, cosmology is specifically how that has changed with time. So it's a study of the history of the universe. So that it does involve studying individual things, but it's more about constructing the overall timeline of how things were different in the past than they are today. So that's the parallel with history. Even though if you study human history, you do end up learning a lot of sociology, and you really need to know the individual things at each time. What you're really interested in, the reason you're doing it, is to uncover the overarching history and evolution of the universe itself, and how it's changed over time, from the very first moments to the late times. Although originally the word cosmology just meant origin. So it was about the origin of everything, the creation of the world specifically. When we talk about the cosmologies in different cultures, we really mean the stories of the creation of the world. And there's plenty of those, plenty of different ones in all cultures everywhere. But the scientific meaning of the word cosmology is to reconstruct this history scientifically. So not only the story of the beginning, but also testing the beginning. And as we found out over the years, the universe wasn't created instantly. It's not like there is one creation story and then it's all over and you're done. It's actually evolved with time, fast at first and slower later, but it has had a lot of steps in between. So the way we got here today cannot be summarized easily. So you have a whole history to reconstruct. So, in practical terms, an astrophysicist will study galaxies, and a cosmologist will study how galaxies appeared and how they evolved, which is kind of part of what I do. So, I am interested, among other things, with the very first galaxies, like the very first groups of stars. Of course, at the very start, galaxies didn't just come out of nowhere. So you have the Big Bang at the start. Let's just assume there was a Big Bang. But the Big Bang only creates gas, and gas is pretty much filling everything. It's very homogeneous. There's no clumps. And at the start, you're only going to get everywhere there's a bit too much mass, you're going to get stars, but they're not going to be galaxies. You're not going to get immediately a spiral galaxy. You're not going to get immediately a Milky Way. The Milky Way comes way, way, way later. So the only thing you get at the start is a bunch of stars speckled round, and then they assemble. They assemble and make little blobs, and little blobs merge to make bigger blobs. And I'll probably talk about this on other occasions too, but that is part of what I study. Of course, as soon as you have stars, you're going to start to have all the related things too. So you're going to start, when stars die, they're going to process elements, they're going to disperse them in the universe. If you have heavy elements, or atoms like carbon and oxygen and all these useful things, you can start making planets, you can start making life. And ultimately, we can answer things like, when did the first planet form? When did the universe become habitable for life? Or what was the first star like? Was it too powerful to have a planet with life? And all these things. Which, to be honest, are not particularly useful, but I think they're very interesting. So in the end, if you do astrophysics, or if you do cosmology, you end up learning a lot about how galaxies work, and where different stars are, how fast they turn, you know, what kind of stars are most common, you know, all sorts of things. But if you're just an astrophysicist, that will be enough for you. Like, that is your topic. If you're a cosmologist, it's a bit harder. You have to put it in the context of the entire universe. That takes a bit more work. Right, so we have finally started. So I don't plan on. This is not supposed to be difficult, unless our tank makes it difficult by aggroing way too much. Right, so I think the reason the distinction between astrophysics and cosmology is poorly understood, or you know, not particularly clear sometimes, is that in the end you end up knowing the same physics. You end up working with the same kind of models. You work with general relativity. You work with quantum mechanics. You do a bit of modeling, or a lot of modeling on computers. In the end, the tools you use are the same. It's just what you're ultimately interested in. So what I specifically do is study this era where the first stars and galaxies were assembled. Not because I particularly care about galaxies. I think that's just a bit of a byproduct. What I specialize in is observing the very first quasars and supermassive black holes. So there's a whole branch of cosmology actually which is obsessed with finding these guys. So these are like if you imagine how big the sky is and how big the universe is, and so far, in the first billion years of the universe, we have only found like about 200 of these objects. So these are quasars that are older than all the things that we can see in our galaxy. They are older than the oldest planets. They are from a time where the Milky Way wasn't even a proto-galaxy. It's an extremely early time. But these supermassive black holes, which power these quasars, were so powerful, they actually emitted so much light that it's just been standing in the universe, just like getting all the way to us, just traveling really, really slowly, until we actually pointed a telescope at them and we actually observed them for the first time. Ah, yes, I see a comment. So I've got the chat up this time. The game name has not been updated. That is a shame. Oh yeah, it has not. I am confused by YouTube. I really am. Aha! There we go. Perfect. Right. So let's... Yeah, sorry about the terrible sound. Sorry for being late. Guys, wait for me. Wait for me. Wait. I know my stream sucks. I'll get better. I still need to improve a lot of things. Alright, well, what was I saying? Quasars. Yeah, we like quasars because they are a lot brighter than galaxies. So, especially at the start of the universe, when stars are really sparse and distributed all over the place, you know, they're not galaxies, which are not even galaxies, they have like 100 stars at the time. They're not bright enough, they're much less bright than the galaxies we see today, and they're super far. So that really combines to make it almost impossible to find them. But quasars, which is active supermassive black holes, they work just the same as they do today. So as long as you have a supermassive black hole and you have gas falling onto it, that gas gets superheated. Like, it's the most efficient E equals mc squared reaction ever known. So the rate of E equals mc squared is different for all processes, right? So you know that you can convert mass into energy, and we do this all the time. So in a fission reactor, for instance, that we use to make nukes and so forth. That's what we do, right? So we take an atom, and then it splits into two other atoms, and the total sum of the masses of the two that are left is less than the mass you started with. That's because the missing mass, which is seemingly disappeared, has been turned into pure energy, following E equals mc squared. You can change them between the two. But a lot of it is lost in energy that cannot really be used. So in a nuclear reactor, you lose, like, for one strange quantum mechanical reason or another, only a fraction of the E equals mc squared power is released. And for conversion of fuel, if you just burn like benzene in your car or gas or whatever your car works with, that's still the same. I mean, that's how we turn matter energy at all levels. And even in your own body, if you eat sugar and it gives you energy, some of that energy has to come ultimately from chemical bonds, which are mass, which then get turned into energy. So I swear I don't suck. This is just because. Okay. I could swear I raised him. Yeah, I did raise him. He just took a fucking billion years to accept my res. Alright, thank you. Thank you, tank. That was my fault. Painful. Alright. We're talking about mass conversion. Right. Most energy sources on Earth use E equals mc squared on some level. It might not always be the same efficiency or the same source. Food is mostly mass in the form of chemical bonds, which are not really mass. But fuel, as in burning gasoline, definitely uses it. And the nuclear power definitely uses it massively. But all these processes are very inefficient, so no more than 1 or 2% of the available energy becomes usable. And quasars have the amazing property of being at almost 50%. It doesn't sound like much. It's actually like 100 times more efficient than the next most efficient process. It is actually unbelievably efficient. It means that even with a small amount of mass falling onto a supermassive black hole, you would get an enormous amount of radiation leaving. And supermassive black holes don't usually eat a small amount of mass either. They heat like whole stars. This is one of the reasons they are so incredibly bright. Now, why do we care? Is because they are so bright even way back at the start of the universe. So as soon as there were supermassive black holes, things started falling onto them, and they were bright, like so bright that we can even see them today. So the light from these quasars has traveled through more than 95% of the entire size of the universe. So it was emitted when the universe was like less than 5% of its current age. And even at all this distance, there has been enough light emitted in all directions that a small fraction was aiming at where the Earth would be one day. So when the light left going towards us, we were not even here. The Milky Way wasn't even here, but it was heading in the right direction already. So I think that's pretty cool. So we use those quasars mostly as torch lights at lighthouses, because they are the only things we can really see in the early universe before there were galaxies. And in that way, we just extract as much information as we possibly can from them. Like we really squeeze all the information that we can, all the science that we can from them. And one of the science things that we can do, using the light from these quasars, when we decompose it in all the different types of lights that they contain, and we can see all the different types of light that they contain, like how much UV, how much visible light, how much infrared light, how many neutrinos in some cases, how much X-ray. We have a ton of details about how exactly what light these guys are emitting. And one of the things we can do with all this information is study the environment of them, because they are shining light on us, but they're also shining sideways, right? So the light that they shine on things close to themselves is going to reflect off, so it's going to illuminate things which are not bright enough to be seen by us on their own. And that's super useful, because that's the only way we have of seeing early galaxies and early stars in any detail, is by the reflected light, or by the light that passes through. It's not always reflected. Sometimes it just passes through, like kind of like through fog. It passes through primordial galaxies, just as a fog. And by looking at exactly what color that reflection is, we know exactly what it's made of. I mean, it works remarkably well. You need a lot of quantum mechanics to work it out, but it turns out that each atom only likes to absorb and to emit one particular color of light. It's very, very precise. Like, that's how we can reach such amazing precisions. That some atoms like carbon, we like carbon because carbon creates life, and carbon is an extremely easy to spot atom. Like it emits always the same color. I guess like the one that we use is like violet, I think. I guess thanks to the power of quantum mechanics. So yeah, that is pretty much what I do. I don't hunt quasars, but I get given them by the quasar hunters.
I shall have to share these findings.
And then I exploit the hell out of them. Like all the information I can possibly get.
Success.
Right, let's try to not die. I have died in this part. Oh shit. Okay, that's not good. I cannot talk about science and at the same time do this. I'm gonna die. They're gonna wipe because of me. I'm so sorry, guys. I am not focused. Come on, please, 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 please. Yes, yes. I did not deserve to live. I did not deserve to live. That was a complete fluke. I am so sorry. Yeah, and despite the Astrologian being a class centered around the mastery of magic, we don't think of magic as sci-fi. Like, technically it is kinda. I don't know. But for some reason all the spells are still based on astrology. They're still, like, you have a tarot deck. You have these different buffs which are named after tarot cards, like the balance and the spire. None of them are actually named after astronomy stuff, like proper astronomy stuff. I don't know why. I guess it's gravity. Right. I like gravity. Gravity is a good spell. Yes. Satisfying explosion. That is exactly why I play this game. Satisfying animations. I mean, that's the entire reason I play Black Mage. It's for the satisfying explosions. I am not even ashamed to admit that. Just big fucking explosions. What more do you want from your games? I keep drawing these shit things, alright. I was talking about my job. Yes. But if you don't look at explosions, what's the point? I can try. There's an explosion. I didn't even look at it. Yep. That didn't change anything. Oh my god. I don't really like healing. It makes me angry. And when I was the Black Mage, I was always blaming the healers for being shit. And like now I feel the pain. Like it's quite a painful job. Especially if you're doing anything that's not top level. I say that even though I died like a little shit earlier. But yeah, it is a thankless job. If I really wanted shorter queue times, I would just play tank. I tried that. It turns out like I'm absolutely fucking terrible at tanking. So I'm not doing that anymore. So I was talking about my job. Right. So one thing I'm currently doing, not me personally, but one thing that our group is definitely using these observations for, of the very earliest quasars, is to look at the origin of the first galaxies, the origin of the first elements of life, and so on. Me personally, I'm more interested in something called Cosmic Dawn. It has a very cool name. Technically, the scientific word is reionization. That doesn't sound as cool as Cosmic Dawn. As at the same time as the first stars were appearing, it's when the universe became properly transparent. So it turns out that even after the Big Bang, when you had all this gas around, right? And then it cools down for a while, and then eventually you get stars. But at the time the first stars form, the universe has become opaque again. It is not transparent. It is filled with a lot of neutral hydrogen. So hydrogen is the most basic gas. It fills literally everything. Like even the space around the Milky Way, which is most of the space in the universe. Most of the space in the universe is empty. It's not really empty. There's lots of hydrogen in it. It's by far the most common thing to find in the universe. But it was not nice and transparent like we see now in intergalactic space. So now we can see our neighbor galaxies, we can see the Andromeda galaxy, a bunch of other galaxies, but at the time where the first stars appeared, it was not transparent yet. It was very foggy. Because that hydrogen had cooled down so much after the Big Bang that all the protons had combined with electrons, and then you form these atoms, which unfortunately are really good at absorbing and scattering all types of light. We don't like it. And you can't see anything. So there was a time where there were stars in the universe and the stars could not see each other. Galaxies could not see each other. And that is really the last time that, in my opinion, the last time something really major and interesting happened in the universe. Right, so you have the Big Bang and all that fancy stuff, and all the crazy physics that come with that, and the universe was not really recognizable. But the last of these major changes, when it became transparent, and then you could really say that the universe looks like what we see today. Before then, you know, it looks weird. You don't expect a universe to not be transparent. You know, that's not right. So that's one of the things I am currently very interested in. I just pressed the wrong button there. That was not even like slightly correct. I mean, as long as we don't die too many times, I guess no one will mind. Right. Let me just... Alright. So the last major thing in the universe, in my opinion, I'm sure... to people who really care about other things, they might say the appearance of the first planet was a major event. I mean major as in making the universe recognizable. Like if you were in a time machine transported back there and you looked out the window, the universe would look like the universe. Like things are into place, you know, like physics makes sense now. Like we're not in the starting stages anymore. Like that kind of thing. And the last of these steps was the reionization. The transparency transition. What we call a global phase transition. I heard a guy who pronounced, instead of transition, like he gave a whole talk when he was pronouncing it transition. He didn't seem aware that was weird. Like I don't know, is that a thing? Do people pronounce transition as transition? And ever since, every time I use the word, I feel kind of awkward. It's like I've been saying it wrong. I don't know. I don't know what the fuck is happening. English is weird. And yeah, and the quasars we have are really good at measuring how reionization happened, like in a lot of detail, because exactly you can pinpoint exactly like this quasar is this far away, and it doesn't let any light through because guess what? The universe was not transparent then, and then look, like 10 million years later, you have this other quasar and it is letting light through. So I guess that's okay, and you can pinpoint like where it happened reasonably accurately. And then we have this whole problem where the reionization happens at slightly different times in different parts of the universe, and no one really knows why. It's a major problem, and none of the models work. You know, and why did some parts become transparent before other parts? And it's all, you know, work in progress. That's what I do. And I mean, if I can use the light from quasars for any other stuff, I usually try it too. Like it's been pretty broad. So I would think of myself as an observer, not because I necessarily get data myself, although I have done that. I have gone to Hawaii to use the telescopes there for one particular quasar that I really cared about. That was a bit of a disaster of a trip. That would be a fun story to tell one day. But no, I do think of myself as an observer because I don't work with equations so much. We have a theorist in our group. Like the only weapon he uses to study the universe is equations and pen and paper and a blackboard. And I'm glad that he's able to explore the universe by just writing equations. I admire that. Although I do think that ultimately, especially when you're dealing with an area where you have no idea what's going on, you always have to test your models. You can if you have a strange observation, you can come up with like 5 different models to explain why it's the way it is. In the end, only data can tell the difference. So I like data. Data is good. You have to be careful. You have to be careful that your model is actually grounded in something, that your model is testable. In the end, you're always going to rely on observers, unless all the observations have already been done, right? Like if I wanted to work on stars, we already have like way enough observations to do that, so I can understand why then it's mostly a theoretical job. Like sorting out details, like the sun. No one understands how the sun works. That's like barely exaggerating. Like we don't understand why solar flares happen, or like how the magnetic fields of the sun work. Like we have all these observations, we have a ton of observations, there's not really much more we can get, and we don't know how it works, right? But in my field we have the opposite problem. Like not only we don't know how it works, but we also have barely any data to go from. So that's not good. So that's what I want to do. I want to come up with new things to observe that will help the situation. And I want to find observations which agree with all models. That's been my favorite thing to do, is when you observe something and none of the models work. And you can just like see in the eyes of the theorists, like they are so sad. Like they are crying inside, like they were so attached to their model, they spent years making it. And in the end, it turns out everyone is wrong, and that's I find that exciting. Like it's when you really have no idea, when you're in the kind of field where you can really throw ideas around and you can't hang to the same model for too long. You're always improving your observations. I'm not a pure observationalist either. I'm not one of the people who hunt for these objects. I might be in the future. I think my career is heading that way now. I will also hunt for them. The first galaxies and stars and quasars and whatnot. But currently I'm just exploiting data taken by other people in new ways. And there's a lot to do. Alright. So I've done my dungeon here. I've got enough tokens to finally upgrade my weapon. So it's gonna be less shitty Look at all these tokens. So much time. So much time to get. And I'm just gonna glamour it anyway. There we go. Yes! That was a long time coming. It looks kinda cool. I'll probably change the appearance anyway. Sorry. Anyway, I think that's all for today. I hope I've fulfilled the title of the video and made it a bit more clear. If anyone was confused between astronomy, astrology, astrologians, astrologers, astronomers, astrophysicists and cosmologists, and I'm sure there's other words too. But hey, I hope you enjoyed this video. I'll probably do this a bit in the future, because I run these dungeons anyway. So if I can talk about random things I'm currently working on, maybe that could be interesting. I don't know. I'm trying a whole bunch of formats at the moment, so I have a new camera and lighting. I've changed the camera position. I'm just trying different things, so we'll see. We'll see. Alright, so I will see you guys next time. Thanks for watching. Good night.